Hello, everybody, and thank you for joining us today for our Insulation Intel webinar, Johns Manville's Low-Temperature Industrial Insulation Products. My name is Kim Melton, and I will be the moderator for today's presentation. Today's webinar is kind of unique in that this is going to be strictly a review of Johns Manville's products that we have to offer. It's a great opportunity for you to get your feet wet, to learn more about our low temperature and our metal jacketing, our low temperature insulation and our metal jacketing. And this is a great resource if you're trying to learn about what products are out there in the market. So with that, let's go ahead and dive into the logistics. First and foremost, we will be taking questions at the end of the presentation today. So if you don't see a Q&A to the right side of your screen, if you simply click on that little ellipsis down the bottom right corner, that's those three dots, it'll open up a Q&A box that you can click on. That'll open the dialog box, and you can use that to submit questions. We'll answer those at the end of the presentation, so please use the Q&A feature to make sure that the questions come through to us to get them answered. Also, today's webinar is for educational purposes only, and it shouldn't be used as a substitute for professional engineering design or documentation that's required by building codes, contracts, or applicable laws. Please also refer to manufacturer-specific application guidelines, instructions, and guarantee requirements on all projects. And those are also those can be found on our website. So we will be following today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can use it to ask any additional questions you may have about the topic of the webinar, or even use it to suggest topics for future webinars. But this survey is part of how we deliver the JM experience to you. Now, the JM experience is based on 4 pillars of the JM culture, and those are listed there in the bottom left corner of the slide. And we believe it's critical to make sure that we hear, understand, and respond to your needs in order to deliver the best interaction to you. So your response in these surveys, that allows us to refine our messaging and make sure that we are giving you the best information that has the most value for you and your colleagues. Also, we're frequently asked whether or not we send out these presentations upon their conclusion. And while we don't send out the presentation itself, we do post a recording of it online. You can watch that or share it with your colleagues at your leisure. As soon as this is live online, we will send you a link to be able to watch it online. And that'll arrive in your inbox. So with that, I'm going to hand it over to our hosts for some introductions. Joining me today are Jim Young and Scott Sinclair. So Scott, why don't you go ahead and kick us off?
Thank you very much, Kim, and good morning, good afternoon, and good evening, everyone, depending on what part of the world you're joining us from. I'm Scott Sinclair, the National Specification Manager for Johns Manville Industrial. I've been with JM in this role for slightly over a year and a half now. I've been working in the industrial insulation field for about 17 years with several different organizations representing different products that are used in those types of applications, and I have a degree in electrical engineering, which does make me somewhat of an engineer, but also someone who can help you with your situations. Jim?
Hello, my name is Jim Young. I'm the Cold Mechanical Insulation and Metal Jacketing Specialist Engineer for Johns Manville. I have an engineering degree from Case Western Reserve University way too many years ago, and have worked in the mechanical insulation industry for about 23 years, performing my current or similar roles. So let's go ahead and get started. The agenda for today's presentation is shown here. We'll first discuss various cold insulation system design considerations. Then we will discuss the JM cold insulation products, vapor retarders, and then I'll turn it back over to Scott to discuss jacketing materials. The design considerations, insulation materials, and jacketing materials that we will discuss today are applicable to the full range of cold temperatures, from slightly below ambient all the way down to cryogenic applications. Some of the insulation materials we will discuss have some narrower portions of this full temperature range or specific applications in which they are mostly used, and we'll discuss these also. Just as one example, XPS pipe insulation billet, widely known as Styrofoam, is mostly used in the application called refrigeration, which tends to be food and beverage manufacture and storage. There are many factors which must be considered when designing a cold insulation system, and some of the key ones are shown here. There is way too much in this topic to cover it in any detail today. We have presentations on this subject alone, and if this would be of interest to you, let us know and we can arrange such a presentation perhaps for your company. The first of the design considerations we'll talk about is, what is the service temperature of the pipe or tank? Is it 40° Fahrenheit chilled water, or is it minus 320 F liquid nitrogen? The system design needs, materials, and system complexity are very different depending on this temperature. What are the climatic conditions? That's the next consideration. Is it indoors in an air-conditioned space, which is probably the least challenging environment? Is it outdoors in a non-conditioned space, which might be a medium challenging environment? Indoors in a non-conditioned space. Is it outdoors in a humid environment, which might be the harshest or most challenging environment? Is it buried below ground? Each of these and other climatic conditions will drive different insulation system design. The water resistance of all cold insulation systems is probably the single most important issue to consider. Using closed-cell insulations with high-quality continuous vapor retarders and jacketing that naturally sheds liquid water are among the key critical design aspects that must be considered. The design criteria for the insulation system must also be considered. Chief amongst these is, why is the pipe or tank being insulated? It sounds a little silly, but it's actually a really important question. Is it for condensation control, heat gain limitations, both, or something else? What is the desired insulation system lifespan? Most of the time the target is 20 plus years, but sometimes shorter or longer lifespans are desired. There are many different categories of materials used in cold insulation systems and multiple material options within each category. When designing insulation systems, all of these must be considered, as well as the interactions between the various material categories and types. Johns Manville offers materials in the 4 categories highlighted in blue here, and we will discuss each of these in more detail later in this presentation. Okay, sorry, I think we jumped here. One of the most important aspects of cold insulation system design is the decision by the specifier on where to operate on what I call the cost-performance continuum. In general, higher insulation system cost yields better long-term performance. Conversely, a lower cost insulation system yields lower long-term performance. However, there is no single point on this continuum that is optimum. This point differs for each specifier depending on which factors are more or less important to them. Usually, higher performance means more redundancy in the insulation system and more backup components. An example of this redundancy would be closed-cell insulation used with a low permeance continuous vapor retarder and periodic vapor stops in the insulation system. Redundancy also will help provide the facility owner time to recognize and find a problem with the insulation system prior to irreparable system damage. System damage is often caused by water entry. If the surface temperature is cold enough, this can form ice within the insulation system. Water or ice will hurt the insulating ability of the system and can cause physical damage, as well as possibly corrosion of the underlying pipe or tank in some cases. Hopefully, if problems are found early, they can be repaired without having to replace the entire insulation system. This is enough discussion of design considerations for now. As you can see, it's a very complicated topic, which Jan would be happy to cover with your companies separately. A really important question to ask ourselves is, why is mechanical insulation important in cold applications? The answer is simply money. As an example of this, consider the hypothetical example I've shown here. I show the cost of energy associated with a single lineal foot of pipe. Remember, this is one lineal foot of pipe for 3 different situations. These situations are bare pipe, a well-insulated pipe using our XPS pipe insulation billet insulation, and a failed insulation system. You can see the design parameters that we have here. They're reasonable ones, and the rough analysis variables that we've chosen to use here. Again, they're all very reasonable. The cost savings for the single lineal foot of pipe achieved by insulating a bare pipe is $229 per year, the difference between $234 for bare pipe and $5 for a well-insulated system. This is way more than the cost of an installed insulation system, and the payback for insulating this bare pipe would be just a few months at most. Next, look at the failed insulation system, which would have an energy cost from heat loss of about $171 per year for this single lineal foot. The cost savings from a failed versus good insulation system is $166 per foot. This would also have a quick, less than 1 year payback time. Insulation is valuable and it pays for itself quickly. The JM insulation materials that we will discuss today are Trymer PIR, Trymer 2550 PIR, which is a special subset of our Trymer PIR insulation line, our extruded polystyrene pipe insulation billet, and our Supercel Phenolic. The first JM cold insulation material we'll discuss is polyisocyanurate, which is such a mouthful that the industry commonly calls this PIR. The JM brand of PIR insulation is known as Trymer PIR. It comes in 3 categories, what we call our standard Trymer PIR, which is also called our high index product line, our Trymer 2550, which has superior fire resistance, we'll get into the details on that in a few minutes, and our Trymer PIR core foam or low index line. Each of these will be discussed separately. Our standard Trymer PIR or high index product line consists of 6 products with the same chemistry and composition. We purposefully control the density in this product line to achieve different strength material. While it's primarily compressive strength that is of interest in the higher density products, all strength measurements, including tensile, shear, and flexural strength, will also increase with higher density. The product name indicates the density. For example, Trymer 2000 is 2 pounds per cubic foot. Trymer 2500 is 2.5 pounds per cubic foot in density. This product line is primarily used as pipe, tank, and equipment insulation from cryogenic temperatures up to the 300 degree F maximum exposure temperature for all of this product line. With the exception of the highest density Trymer 6000 product, all of these have the same thermal conductivity performance with a very good value of 0.19 at the standard 75 degree F mean temperature. As you can see, the compressive strength increases as the density is raised, and our highest density Trymer 6000 actually has higher compressive strength than standard cellular glass. All of these products are closed cell and water resistant and all meet the flammability requirements to be considered Class A or Class 1 for pipe insulation in the building codes, which is an ASTM E84 flame spread smoke developed rating of less than or equal to 25 flame, less than or equal to 450 smoke. These materials can be used anywhere in industrial applications and even in those commercial building applications where a 2550 rating is not required. Trymer 2000 XP is our workhorse product and is used on pipe and equipment. Trymer 2500 is primarily used on LNG pipe at minus 265 degrees F. The higher density Trymer products are primarily used in pipe support locations and in specialty applications. All Trymer PIR is made and supplied in the form of large rigid buns, which are fabricated into standard 3-foot long pipe shells or other shapes. Trymer 2550 is a special product in our Trymer PIR line. It is an ideal material for use in cold and warm applications that require a flame smoke performance of less than or equal to 2550. This includes pipe insulation in plenums, where the 2550 or lower performance is required by codes, and in general pipe insulation used in commercial buildings, where a 2550 performance, while not required by code, is often specified by the specifier. Aside from this very good low flammability performance, Trymer 2550 has the same great performance as our Trymer 2000 XP. It has an upper temperature limit of 300 F, a K factor of 0.19, and is closed cell and water resistant. The main application for this product is commercial building chilled water applications, where it provides a closed cell water resistant insulation alternative that meets a 2550 flame smoke rating. This 2550 flame smoke rating for Trymer 2550 is applicable only up to 1.5 inches of thickness. But the need for larger thicknesses than this in commercial building chilled water pipe insulation applications is very rare. The last of our Trymer PIR product lines are the core foams or low index line. These Trymer PIR products also come in a variety of densities and strengths, with the name still indicating the density. Each of the products in this line has an L at the end of it to indicate that it is part of our low index line. So Trymer 200L, 250L, etc. All of these products have the same good low thermal conductivity of 0.19, are closed-cell and water resistant, and are supplied in the form of large rigid buns that can be cut into whatever shapes are needed. The key application for the Trymer Core or L series products is in insulated panels, panelized construction, military shelters, and other specialty applications. This line is lower in index, which yields a material which is easier to glue strongly, that is, it adheres well using glue to the facers, and facers are necessary for most panel applications. Here are 3 frequently asked questions about Trymer PIR. I'll give you our answers to these. The first, can Trymer PIR be used at temperatures below -297 F? Trymer PIR is an excellent choice for use on pipe vessels and equipment operating at temperatures down to -460 degrees F, absolute zero, including liquid nitrogen at -320 and other cryogenic temperatures. The JM product literature states that the lower temperature or lower service temperature limit for Trymer PIR is -297 F, which is the boiling point of oxygen. That's a key point. Trymer PIR pipe insulation does not have any inherent physical or thermal properties that would preclude its use at temperatures below this published limit. Nothing changes in the product below -297. This -297 limit is cited only as an attempt to caution end users that, as with all insulation types, if the service temperature will be below -297, there are important design concerns that must be considered. These design concerns center on the fact that at service temperatures below -297 F, oxygen from the air can begin to condense on the cold pipe surface or in the cells of the insulation near the pipe, resulting in local regions of higher liquid oxygen concentration. Also, if the pipe subsequently warms up, there could be a thin region of air within the insulation system with higher than normal levels of oxygen. Either situation poses a flammability and reactivity concern, regardless of the type of insulation, sealant, vapor retarder, or jacket used. JM has more information on this issue if you are interested, and if you are interested, please contact us. The next question, what thickness Trymer PIR should I use? The answer is, it depends. The needed thickness depends on many factors, include what I mentioned earlier in the design considerations. Why are you insulating? Is it for condensation control, heat gain limits, both, or something else? It also depends on the pipe temperature, the climatic conditions, pipe size, and even the type of jacketing used. JM has much more information on this and can perform insulation thickness calculations for you to determine the thickness needed for your particular situation. The last question we'll cover today on this FAQs is, can I use Trymer PIR at support locations? The answer is usually yes, but it depends. In a surprisingly large number of situations, the strength of our standard Trymer 2000 XP is enough to allow its use at support locations. If higher strength is necessary, the higher density grades of Trymer PIR can be used. JM can perform the necessary strength calculations for you to determine the grade of Trymer PIR needed at your supports. This will depend on many factors, including pipe size, pipe contents, pipe schedule, span between the supports, and length of the metal shields at the support locations. The next JM cold insulation product line we will discuss is extruded polystyrene pipe insulation billet, often called XPS PIB or Styrofoam. XPS PIB is made by DuPont, but is sold, and all of the technical support is offered by Johns Manville. XPS PIB is another great cold temperature insulation. It has a maximum use temperature of 165 F and a lower temperature limit of -320, which is the temperature of liquid nitrogen. It has a good thermal conductivity of 0.259, which is not quite as good as or as low as the Trymer PIR. It comes in only one density, which can be used at some pipe support locations, but if higher strength is needed at supports, the high density Trymer PIR would be what should be used at those supports, with the XPS pipe billet used in the bulk of the system on the pipe or tank. Pipe billet, XPS pipe billet is closed cell and very water resistant, even better at this property than Trymer PIR. XPS pipe billet is used primarily in refrigeration piping, including ammonia refrigeration. The most common use for XPS pipe billet is as pipe or tank insulation in food and beverage manufacture and storage. It is sold in long billets, which are fabricated into standard 3-foot-long pipe shells or other shapes. Here's 3 frequently asked questions. about XPS pipe billet. XPS pipe billet enjoys immense popularity in refrigeration, food, and beverage applications, but why is this? It's for two reasons. First is the old adage that nothing succeeds like success. For pipe billet, what this means is that pipe billet has a 30-plus year history of excellent performance in this application, so there's no reason for specifiers to change. The second reason is the underlying cause for the long history of good performance, which is that pipe billet has the properties necessary for this application. It has excellent water and water vapor resistance, good thermal performance, and is clean to cut and fabricate in the field. The next question, can XPS pipe billet be used in heavy industrial oil, gas, or petrochem applications? The answer is no, not usually. XPS consists mostly of polystyrene foam. This polymer is soluble in most common organic solvents, including gasoline and oils. About the only common solvents that will not dissolve it are alcohols. If used in oil gas application, leaks of the commonly encountered chemicals would damage the XPS pipe billet, harming the performance of the insulation system. Conversely, the pipe contents in the food and beverage applications for XPS pipe billet is usually used will not damage it. These include things like ammonia and common refrigerants, and of course the food and beverage that might be in pipes as well, which would be probably water-based. The last question, how does XPS compare to expanded polystyrene, often called EPS or beadboard? EPS beadboard is the same basic material, polystyrene, and it's the material that's used in white foam coffee cups and some cushion packaging. XPS pipe billet is much more water resistant than beadboard. Pipe billet is nearly 100% closed cell, while EPS is mostly an open cell material. Each little bead in the EPS is closed cell and behaves like XPS pipe billet, but there are interconnected voids between the EPS beads through which water or water vapor can pass. This is shown better on the next slide. Here you see some photomicrographs with XPS pipe billet on the left, and as you can see, each cell is intact and there are not voids between the cells. Compare this to the picture on the right of beadboard. You can see that each little bead in the beadboard has closed cells, but there are voids between the beads that allow water and water vapor to pass through it readily. JM has videos of water-based ink injection into both materials, and these clearly demonstrate the comparatively poor water resistance of beadboard, the ability of water to flow through it pretty readily. If these would be of interest to you, let us know. Let's talk briefly about JM's Phenolic insulation product line. This product is called Trymer Supercel Phenolic insulation. It comes in various densities and strengths as are shown here. The upper temperature limit is 257 F, and the same lower temperature limit previously discussed of minus 297, but really absolute zero, apply. Like Trymer PIR, Trymer Supercel Phenolic is closed cell and water resistant and has a very good low K factor of about 0.18 for the standard 2.5 pound per cubic foot product. The higher density grades of Trymer Supercel Phenolic can be used at pipe support locations if necessary. The key benefit of Trymer Supercel Phenolic is very good low flame smoke performance. It meets a flame smoke of less than or equal to 2550 at thicknesses of up to 3 inches. So let's talk about a couple of FAQs for the Trymer Supercel Phenolic. What is the benefit of Trymer Supercel over Trymer PIR? The key benefit of phenolic insulation compared to Trymer PIR is that the phenolic has a lower, that is better, flammability. It meets the less than or equal to 2550 flame smoke requirement in plenum applications at up to 3 inches thickness, whereas Trymer PIR only meets it at 1.5 inches thickness and less. For those very rare situations where a 2550 flame smoke performance is required and an insulation thickness greater than 1.5 inches is also required, Trymer Supercel Phenolic would be the ideal solution. The next question, I've heard that phenolic foam can contribute to corrosion. Is this accurate? No, it really is not accurate. In the past, there existed a category of roof insulation made from phenolic insulation. This roof insulation was strongly linked to extensive problems with corrosion of the metal roof deck. Lots of lawsuits related to that are still making their way through courts. Compared to the problematic phenolic roof insulation, the phenolic pipe insulation, the Trymer Supercel, that's currently being offered, including our products as well as others, it uses different chemistry from the roof deck material. Our products have a much higher, that is better pH, and it does not cause corrosion of the underlying pipe or tank. JM has extensive information on corrosion under insulation and would be happy to share this with anyone desiring more details. The short answer is that CUI, corrosion under insulation, is best addressed by keeping environmental water with its associated inexhaustible supply of chloride ions out of the insulation system. This should be accomplished by using closed-cell insulation line, like any of our JM cold insulation products, a high-quality continuous vapor retarder, and other aspects of proper insulation system design. Let's change tack slightly and discuss the JM vapor retarder product line used with the insulation materials we have discussed and even with other insulations. The JM vapor retarder line consists of Saranex CX Film and Tape. The film is available in two grades, 540CX at 4 mil stick and 560CX at 6 mil stick. Both are clean-looking, bright white materials that are usually factory applied to the outer surface of the insulation, like many other vapor retarder types, but can also be field applied if so desired. When factory installed, they have the standard self-sealing lap tape present to seal the longitudinal joint. Compared to 540CX, the thicker our thicker 560CX is stronger, stiffer, and more opaque, in addition to having a little bit lower permeance. Both products are available in lengthy rolls at the optimum vapor retarder width of 35.5 inches to fit on insulation pipe shells. Both are ideal for use in all cold to cryogenic applications, where they are the key components in the insulation system that resists the entry of water and water vapor. Both products meet the industry standard performance, which is less than or equal to 0.02 perms, and Saranex 560CX has an even lower permeance of 0.01 perms, which makes it ideal for very cold and cryogenic applications, say anything below 0 degrees F. Saranex CX tapes are based on the Saranex CX films and have the same excellent low permeance. They come in various widths and thicknesses to spiral wrap around various sized insulated fittings and elbows. Saranex CX tape is used to apply a vapor retarder to complex shaped areas such as elbows, fittings, valves, etc., as well as to seal the butt joints between adjacent sections of the vapor retarder film. The CX tapes have an adhesive applied to the back side which does not require the presence of release paper, making it a little easier to install and handle than many other vapor retarder tapes which come with release paper. Here are some of the key benefits and reasons to use Saranex CX Film. Both types of film surpass the most stringent industry standards for permeance of vapor retarders used on cold pipe and tank applications. The film is strong and resilient with great puncture, abrasion, and tear resistance. Both films have excellent low flame smoke performance. Both easily meet a less than or equal to 2550 rating. The films offer great installation flexibility. They can be field or factory applied. They have great chemical resistance and abrasion resistance. The films can be used without jacketing indoors, where it closely matches the color and appearance of white PVC jacketing. It can be exposed to weather outdoors for up to about 14 days, which can allow earlier system startup. And here are some reasons to use and key benefits of the CX tape. The tapes have the same great low permeance as the base films. They provide excellent adhesion. They're flexible and conforming for spiral wrapping around fittings and elbows. They do not have release paper, which makes them easier to install and handle than vapor retarder types that do have release paper. The tapes can be used to patch holes in the Saranex CX Film vapor retarder. And the CX tapes are easy to install, which reduces installation costs. That ends my section, and I'll now turn you over to Scott Sinclair, who will discuss our metal and PVC jacketing lines of products.
All right. Thank you very much, Jim, and thanks for that excellent overview of our foam insulation and vapor retarder products. And as Jim just said, I will now take us through a discussion on JM's metal and PVC jacketing solutions. As many of you, I'm sure, know, metal jacketing is one of the primary components used in an insulation system to provide protection to the underlying insulation. Insulations used in most industrial applications do require some type of an external protective layer to provide abuse resistance, so protect the insulation system from damage due to mechanical impact, like people walking on pipes or things getting dropped on it, as well as providing weather protection to the underlying insulation and pipe or equipment keeping water out of the system and protecting the insulation system from potential long-term UV or ultraviolet light exposure, which will degrade most insulation materials. In addition to that, your metal jacketing system is your first line of defense to provide protection against corrosion under insulation. So it is the first element that is going to be used for keeping water out of your insulation system, which is crucial for the successful operation of most insulation systems. JM has a very wide range of metal jacketing products, as you can see here on this slide, and we'll talk about most of them in more detail as we continue through the presentation. There are a lot of complex aspects in terms of how metal jacketing is installed on pipes, tanks, and equipment, and we're not going to go into detail today on installation techniques and methods, but if you do have installation questions, please feel free to contact us, and we'd be happy to discuss this with you in much more detail. We also have a very thorough line of installation guides available on our website for you to download and use as necessary. The specific categories of metal jacketing products that we're going to cover today are our roll jacketing, the sheet jacketing, and then our two-piece pressed elbows. We also have a line of metal jacketing accessories, including banding, seals for securing the banding, screws and springs, but due to time constraints, we're not going to get into a detailed discussion on those today. But if you do have questions, once again, please feel free to reach out and ask, and we'll share more information with you. We're also not going to go into the details on this, but all of our metal jacketing products do meet the applicable ASTM standard requirements for the metal jacketing standards, which are C1729 for aluminum and C1767 for stainless steel, as well as meeting the applicable metal alloy standards such as B209 for aluminum. But before we start talking about the metal jacketing products themselves, one important area to talk about is the polyfilm moisture barrier or moisture barriers. As you can see from the chart on this slide, there's several options of moisture barriers available. The moisture barrier is a film or coating that's applied to the interior or the hidden surface of the metal jacketing, whose primary purpose is to provide a protective layer on the inside of the metal to keep it from being exposed to water that might get into the insulation system and thereby start to corrode the metal jacket from the inside out. The picture on the, what happened here? There we go. The picture on the lower right shows you an extreme example of corrosion of the metal jacketing. It actually looks like it would be corrosion from the outside, but it was actually corrosion that started from the inside and progressed to where it completely perforated the metal. There are three types of moisture barriers available within the industry: painted coating, a polycraft, and a polyfilm. And you can see the key properties for each of them represented in the slide on the left. Again, we're not going to have time to go into detail on each of these, but you can see for each of the critical parameters listed, the varying levels of protection that each of the different products does provide. And we have extensive literature available, as well as individual presentations discussing the critical importance of moisture barriers and the comparison of the performance on each of those. So again, please feel free to contact us for more information, but please be aware that there's extensive information available as demonstrated through corrosion science, through lab testing, and through real-world test results that all point out how important it is to use moisture barriers on the interior of your metal surface, as well as demonstrating the superior performance of the polyfilm type of moisture barriers. It's also important to know that polyfilm is not a proprietary product, and it is available as an inner coating from most manufacturers of metal jacketing material. And we highly recommend that all metal jacketing systems be specified to use a polyfilm moisture barrier. Next, we'll talk about our metal roll jacketing. And as you can see from this slide, we offer our metal roll jacketing in various types, all with lengths between 50 and 300 feet. We have a aluminum with a bare exterior, and that is our standard aluminum product, which provides good corrosion resistance just due to the natural corrosion resistive nature of aluminum. We also have a line of aluminum that has a painted exterior, which offers a slightly improved level of corrosion resistance, as well as a different aesthetic appearance, which might be desirable in some applications. And lastly, we have two grades of stainless steel, T304 and T316, which provide superior and excellent corrosion resistance respectively. In addition, stainless steel jacketing is typically specified when the requirement includes the need for fire resistance or fire protection. So therefore, aluminum typically won't provide the level of protection needed in a fire situation, whereas stainless steel will. All of our roll jacketing is stocked in standard 3-foot widths, but there are other widths available, and you can inquire about those. All our roll jacketing is also available with either a smooth, a stucco embossed, a 316 or a 316 corrugated finish. The choice of finish, once again, is mostly based on aesthetics, though oftentimes people will choose the stucco or a corrugated finish because the smooth finish can reflect sunlight, which may be undesirable in certain situations. The type of metal that is selected, aluminum or stainless steel, will influence the appearance as well as the emittance. Bare aluminum is quite shiny and has a very low emittance of 0.1. Painted aluminum can be different colors and has an emittance of 0.5 to 0.8 depending on the type of paint. And stainless steel has a dull mill finish, which usually will have an emittance of about 0.3. For insulation systems design where the outer surface temperature is important, where situations where you might be designing for personnel protection or condensation control, a lower metal jacket emittance will usually require the use of a greater insulation thickness, or conversely, a product with a higher emittance will result in a thinner requirement for the underlying insulation material. JM also offers all of our roll jacketing products with a polyfilm moisture barrier on the interior surface to once again help protect it from corrosion of the jacket from the inside out. The next product in our metal jacketing line is our acoustical metal jacket, referred to or called Muffl-Jac. This product is also sold in rolls. It is a slightly thicker aluminum, a 0.020-inch aluminum jacket that's laminated to a 1-pound mass-loaded vinyl layer. This added mass provides a higher mass outer layer to your insulation system, which can help absorb, dampen, and block the transmission of sound, which is emanating from the insulated pipes, tanks, or equipment. So it can be an important element of your insulation system where acoustic control is important. The next product in our line is our cut and roll metal jacketing, which comes in the same metal alloys, exterior surfaces, and finishes as our roll jacketing. This product line is identical to the metal roll jacketing, except for the fact that it is pre-cut in our factory to fit around the insulation of a specified size. So we have pre-cut configurations to match the circumference of the required insulation system that's being insulated, and it does include a standard 2-inch overlap at the longitudinal joint, and as an option can include a 1/2-inch safety hem. The next product in our portfolio of metal jacketing is our deep corrugated sheets. These again are our standard metal jacketing that's cut to length and has a sine wave pattern pressed into it, as you can see in the two graphic images on the right-hand portion of the slide. These are available in either aluminum or T304 stainless. The exterior surface or finish is unpainted, so it has the natural emittance of the metal that's used, which is 0.1 for aluminum or 0.3 for stainless steel. The interior surface does have the Polyfilm moisture barrier on it. These products are typically stocked in a standard width of 33 inches and standard lengths of 8, 10, and 12 feet, and the metal finish can be smooth or stucco embossed. We offer 2 corrugation patterns, as shown in the chart, a 1 1/4 by 1/4 inch and a 2 1/2 by 5/8 inch. Deep corrugated sheet is often used on vertical vessels larger than 8 foot in diameter or other large tanks and equipment. It should never be used on horizontal vessels because the troughs lower portion of the corrugations will collect water, which can lead to corrosion over time, as well as create an opportunity for water to enter the jacketing system through the overlapping joints and adjacent pieces and panels. Our next product is the box rib sheets, again fabricated from our standard metal jacketing cut to length, but these have a square wave pattern pressed into them as opposed to the sine wave pattern. They're available primarily in aluminum and specifically the Al-clad alloy, which does offer a very good corrosion resistance. T304 stainless steel option is available, but we rarely see that utilized. The exterior surface is unpainted, so again it has the emittance of the natural metal alloy, which is 0.1 for aluminum. Typically stocked in 2 standard widths of 27 1/2 or 38 1/2 inches, and the same standard sheet lengths of 8, 10, and 12 feet. The metal finish is stucco embossed, and the rib pattern is as shown in the graphic image, a 4-inch pitch with a 1-inch depth to the corrugations. The purpose of the box ribs is to provide added structural strength or support to the jacketing system. Box rib sheet is most commonly used on power plant breachings, large vertical vessels, or other large pieces of equipment, and again should never be used in a horizontal application or orientation, as it will also collect water in the box rib corrugations, which can lead to corrosion or entry of water into the insulation system. Stepping into the next line of products within our metal jacketing portfolio, we'll take a look at our 2-piece elbows. These are an excellent alternative to miter or gore fabricated elbows. We offer these in both aluminum or Type 316 stainless steel in multiple sizes and shapes to fit various pipe sizes and insulation thicknesses. We have 2-piece metals for both 45 and 90-degree elbows, as well as short and long radius. And we have a complete line of elbows that we call multi-fit that we'll talk about in more detail a little bit later, that are designed to fit multiple sizes rather than an individual size. 2-piece metal jacketing elbows offer quite a number of advantages over miter or gore elbows. They offer much faster installation and can typically be installed by a less skilled labor force, both of which provide significant cost savings. They can shorten a project timeline, and everyone knows that with a lot of industrial projects, with insulation being one of the last pieces of work to be completed, and the project is already over budget and behind schedule, it's very important to facility owners to try and get it done as quickly as they can, so a very valuable benefit. 2-piece elbows have fewer joints and much shorter total joint length, therefore reducing the opportunity for water to get into the insulation system and degrade its performance. They also provide what many people believe to be a superior aesthetic or look or cosmetic. Lastly, the mitered elbows have a tendency to gap at the joints, as seen in the left, as the result of natural expansion and contraction of the insulated pipe system, whereas the 2-piece elbows do not have that problem. You can see a good picture at the top right of the slide showing a nicely installed 2-piece elbow with a very clean finished appearance. It's vital that the proper 2-piece elbow be specified for a given situation. As we said, it is dependent on the pipe size and insulation thickness, so it's very important for you to consult with JM for more help in making sure that you are selecting the proper sizing of the two-piece elbows for your particular applications and requirements. Within our elbow family, we have a line of two-piece elbows made out of the standard aluminum called Ell-Jacs Plus. These are an 1100 alloy aluminum two-piece elbow that are lined with the Polyfilm moisture barrier. Johns Manville is the only jacketing company that does offer the two-piece elbows already with a Polyfilm moisture barrier installed on the inside of the elbow. These provide an extra level of protection with the Polyfilm moisture barrier to reduce the likelihood of jacket corrosion on the interior surface, which can definitely be an issue at the bottom of vertical pipe runs where water might have a tendency to collect. Elbows from the other jacketing manufacturers and suppliers typically only have a painted moisture barrier, which does not offer an equivalent level of protection against corrosion that is provided by the Polyfilm moisture barrier. The Polyfilm moisture barrier on the Ell-Jacs Plus line is the same as that is on our roll jacketing or the cut and roll products, so you are going to get the same performance through the entire jacketing system. They're fully compliant with all of the relevant ASTM standards and made to fit for pipe elbows from 1/2 inch up to 12 inch. And they're also designed to have increased spacing between the ribs and fingers to make it easier to install the banding for cold applications. Let's take a look at a few questions that we very frequently get asked with regard to our metal jacketing line. The first is why should I use stainless steel over aluminum? And there's several different reasons why that might be the best choice to make. The first is for corrosion resistance of the jacketing itself. When you're looking at stainless steel, T304 is going to be more corrosion resistant than bare aluminum, and T316 is going to be more corrosion resistant than T304. 316 is commonly used in your offshore applications where you're going to have constant exposure to a salt water and salt atmosphere where corrosion can be a significant problem. Another reason for selecting stainless steel over aluminum is fire resistance that I mentioned earlier in the presentation. The melting point of stainless steel is about 2,500 degrees, whereas aluminum is 1,200. And in rare cases where an insulation system is intended to help provide fire protection to pipe tank or equipment from the fire, aluminum will not provide adequate protection and stainless steel must be used. Last choice would be for physical strength. Strength of stainless steel is much higher than aluminum, but this can also be mitigated by thickness. Thicker aluminum obviously is going to provide more protection than thinner aluminum, and then your stainless steel will provide better protection typically than the aluminum. Next question we often get asked is what's the benefit of painted aluminum over regular? Painted aluminum, as we talked about, provides a higher emittance than bare aluminum. So for those insulation systems where the emittance has a significant impact on your insulation thickness, looking at condensation control or personnel protection, painted aluminum will result in a thinner insulation requirement. Also has a higher resistance to corrosion than does bare aluminum, and it may also be selected for aesthetic reasons if you're trying to match other jacketing or surroundings within the application. Last question is what thickness of jacketing should be used for a given pipe size? And as Jim commented in one of his questions, the answer is that depends. The decision is based on the tanks and larger pipes yielding a larger surface area, which could be potentially be dented and therefore needing increased jacketing strength or thickness to resist denting. In addition, if you are using a flexible insulation material like elastomeric rubber, fiberglass, or mineral wool, which don't provide a lot of contribution toward dent resistance, then a more rigid jacketing system or a stiffer jacketing system would be required. The ASTM standard for aluminum jacketing, C1729, does contain a table with recommended jacketing thicknesses based on pipe size. And then the C1767 standard for stainless steel also gives the same recommendations. Next, we'll branch and take a quick look at our PVC jacketing line. And once again, PVC jacketing is utilized to provide protection to the underlying jacketing system against possible mechanical damage from impact or other potential damage risks, and also can be used to provide color identification, which is very frequent in certain industrial applications, especially utility rooms, chilled water systems, and things of that nature. So you can use the color to readily identify what is contained within the piping system. Our PVC product line is called Zeston, and as you can see, we have several products within the Zeston product line. The Zeston 2000, which is a series of fittings, molded fittings, as well as our Zeston 300, which is similarly a line of molded fittings. And the last product in the Zeston line is our cut and curl jacketing. All three are available in 14 different colors. You can see the difference between the Zeston 2000 and 300 fittings is the thickness or millage, with the 2000 being a 20 mil product and the 300 being a 30 mil. The cut and curl jacketing is available in both thickness options, 20 or 30 mil. All are rated for an operating temperature range of 0 to 150 degrees Fahrenheit, but you have to remember that this is typically being installed over your insulation system, so it can be applicable to systems operating at temperatures higher than that. A lot of different selection sizes available for the fittings. The standard lengths of the cut and curl is 3 foot and 4 foot, and you can see as well that the applications for this are typically commercial for the thinner grade Zeston 2000s, high abuse applications or USDA specific applications for the higher thickness Zeston 300s, and again high abuse or USDA for the cut and curl products. Some quick FAQs for the PVC product line or Zeston fittings. How do I determine the right size for my application? The proper size for Zeston cut and curl jacketing and fittings, as I mentioned earlier, depends on both the pipe size as well as the insulation thickness. So it's the outside circumference or diameter of your full insulation system. We do offer convenient sizing charts that are available off the mechanical insulation portions of our website that you can download for easy reference. Next question is, can Zeston products be used outdoors? And the answer is yes, they can, but they should only be used in areas where they're not going to be consistently exposed to direct sunlight or at high risk of repeated mechanical impact, walked on, or having heavy things dropped on them. Areas like a fully shaded parking garage might be a good area to use a PVC jacketing system. Our white Zeston fittings do have a UV resistant component, so they can be used in areas where occasional sunlight exposure might happen. But for areas where you're going to see consistent direct sunlight exposure or significant risk of mechanical impact, metal jacketing should definitely be used. And as I mentioned earlier, all of our Zeston fittings and products are available in 14 different colors. And with that, I will complete my portion of the presentation and hand things back over to Kim to wrap things up for us.
All right, thank you very much, Scott. So we will answer questions. We had a lot of cool questions submitted, and I see that we only have about 7 minutes until we hit the top of the hour. So we will answer questions up to 15 minutes past the hour. Anything we don't get to today, we will reach out to you separately in a private email offline so that we can get your questions answered. Also, in the survey after the webinar, you can submit any questions that you were not able to have answered today, and we'll get to those privately. Today's webinar will be available on the source. This is where we host all of our recorded webinars, also access to our ebooks, blogs, technical documents, products, and online tools that are available. And we will have a certificate of completion available for you. That'll be in your inbox by next week, so keep an eye out for it. And if you don't have it, if you can't find it or it gets dropped in your junk mail, please reach out to us. We'll be happy to make you one and get it sent to you directly. So with that, I'm going to take us into some questions. Jim and Scott, are you guys ready?
Fire away.
All right, excellent. Jim, the first question is for you, and that is, please provide a comparison between fiberglass and Trymer and let us know which one is best for chilled water applications.
Well, I don't really think there's a best. It's more of a horses for courses situation. Fiberglass is an open cell material and less resistant to water, but it's lower in cost. So there are pros and cons to both products. I think the fiberglass is probably a great product to use on chilled water in an air-conditioned space. So inside of a commercial building in the conditioned spaces. In non-conditioned spaces, whether it's indoors or outdoors, and there are plenty of non-conditioned spaces even in commercial buildings, I think a closed cell material like the Trymer PIR would be a better option.
All right. Thank you, Jim. Next question is also for you, and that is, how does your spray foam compare to your sheets of Trymer insulation, and which one do you recommend?
They really aren't used at competing with each other. They're more complementary products. In mechanical insulation, the prefabricated tank insulation pieces or pipe insulation pieces would be used, but there are unavoidable voids or gaps between some of these pieces, particularly if you're dealing with a complex shape. The spray foams would be used along with the Trymer to fill the gaps between them or to fill voids where they exist. So both products are used complementary to each other.
Excellent. Thank you. Next question is also for you, and then Scott, if you have anything to add, please feel free to weigh in on it. But is it possible to utilize open cell insulation to prevent sweating of a cold water line and heat trace the line to prevent freezing in the winter?
Let's take that as two parts because I don't think they're really related. The first part is it possible to utilize open cell insulation? Yes, it is, but if you're getting sweating, you're in a humid environment, which is most likely not a climate-controlled environment then, and I think an open-celled material like beadboard or like fiberglass is probably not the best choice in that environment. So you could certainly use insulation to prevent sweating. I would recommend a closed-cell insulation if condensation control is your big concern. The second half of the question of can you heat trace the line to prevent freezing in the winter? The answer is absolutely, but it's unrelated to the insulation open cell or whatever. You can use heat tracing, both electrical and heat transfer fluid type of heat tracing underneath insulation of any sort. Again, if you have insulation that's performing functions in humid environments in the summer and cold environments in the winter, you're probably better off with a closed cell insulation. And the heat tracing would need to be, the insulation would need to be selected such that it could handle whatever temperature the heat tracing was going to get to. That's probably only going to be a concern if extruded polystyrene was the insulation chosen with its upper temperature limit of 165 F. The other products with temperature limits above the boiling point of water would probably be able to handle any temperature that heat tracing would reach.
I guess just to add one additional comment to what Jim said, something that he pointed out very well during his discussion is any cold insulation system, especially where you're looking at condensation control, it's important to remember that you wouldn't just use the insulation material by itself. So, comparing your open cell to your closed cell product, both are still going to be used with an integral or field applied vapor retarder product. So the entire insulation system needs to be considered when you are looking at condensation control.
All right, thank you both. Jim, the next question is for you, and that is, do you recommend insulating irregular forms like low temperature valves with a Do you recommend insulating irregular forms like low temperature valves with a 2-component injection foam?
There's lots of ways to handle complex shapes like the low temperature valves that were mentioned. One of the ways is to work with a fabricator to get a custom fitted insulation piece made. And many of the fabricators have the details on the sizes and shapes of these valves and can cut out two pieces of insulation, just like two pipe shells, that will mate around the valve. That's probably the ideal way. It doesn't leave any gaps. If that's not the best option for your particular situation, the other two options usually involve building some sort of box around the valve and then filling the voids between the walls of the box and the valve with one of two things, either spray foam or some kind of fiberglass batting. Both of those have pros and cons. The batting has to be stuffed in there and it can be a little awkward to get in. The spray urethane foam, the two-part component urethane foam, will fill the voids much better. But if the valve is one that undergoes frequent maintenance, that spray foam sticks tenaciously to any surface it touches. So if you have to get into that valve and remove the insulation to get at the valve for maintenance purposes, it can be very difficult to remove the two-component spray foam. So you might consider fiberglass stuffed inside of the insulated box and vapor retarded box as an alternative. There are ways around that. You can try and put various barriers around the valve to prevent the sticking, but the spray foam can still cause some problems. So it just depends upon your particular preference and your situation.
All right. Thank you, Jim. You're still in the hot seat, so we'll keep going. And that is, what solution do you have since Canada and 16 U.S. states have banned HFC and CFC-containing products?
It's not that simple as a ban. Well, certainly it is for CFC. For HFC products, it's not as simple as a ban. It's a limit on the global warming potential, the GWP, of the materials being used. Of the insulation products we talked about today, the Trymer PIR line and the Supercel Phenolic use hydrocarbon blowing agents, so they contain no HFC or CFC materials. The Styrofoam, the extruded polystyrene pipe insulation billet, does contain HFCs, and we are working with the producer of that, DuPont, to generate a new product that will be compliant with the new low GWP requirements. We expect that to be happening in the next 6 months. We're working very closely with them. We have stockpiled material which will be suitable for use in these states or in Canada or any other states using the older blowing agent material. The way the laws read is that material produced before January 1 of this year can utilize the higher GWP. So that's going to be what we use to provide material for the next few months until we and DuPont generate the next product that will be compliant with the latest GWP requirements. This new product will, by the way, be gray. Just for those of you who might be used to the blue styrofoam, all styrofoam board stocks that DuPont makes, as well as the pipe billet, are going to go to a gray color. That's proved necessary to retain the good thermal conductivity that the product has.
All right, thank you, Jim. The next question is, I'd like to know more about online cold insulation repair methods when icing is noticed during plant in operation.
I'm not sure what online means in that, more about online cold insulation repair methods, so I'm going to skip the word online. The key thing in this sentence is icing. If you've got condensation on the outside surface of insulation, that might be an indication that you don't have enough insulation. That might be an indication that if you do have enough insulation, that you've started to get some water in there and the insulating ability is a little bit damaged. If you truly have icing, icing is an indication that your vapor retarder system has failed, you've got plenty of water in there, and the surface temperature, the outer surface temperature of your insulation is at or below freezing. That's really bad. So when icing forms on an insulated system, that system is not working very well. If you recall early in the presentation, I talked about the cost savings of a bare pipe, a good insulation system, and a failed insulation system. In order to determine the performance of a failed insulation system, I modeled that as iced up insulation. So you can see the kind of money you're spending on energy for an iced up insulation system. In that particular example, it was $166 per year per lineal foot. It would pay for itself very quickly to replace that insulation system if it is truly iced up. And when you do, we'd be happy to work with you to talk about a better quality system that's going to have better lifespan and better resist water entry, which is usually what has caused the formation of ice. I think that answers the question.
All right, thanks.
Just to expand on that a tiny bit, another important factor to keep in mind when you are having icing on your insulation system is not just the point that Jim made with regard to loss of efficiency and therefore increased operating costs, but also the potential safety risk that it can pose. Typically, if your insulation system's icing, you are going to get a situation where the outer layer of ice is melting and dripping, and so you're going to be creating pools of water all over your facility, and that can definitely create a safety hazard. So there are many reasons why it could be very important to get that repaired as quickly as you can.
All right, thank you, Scott. Jim, the next question is for you, and that is, has your low-temp insulation line been used in any space or mil-spec applications, and do you actively work with any aerospace companies?
The second half of the questions is yes. We've worked with various aerospace companies. We're not going to discuss particular names. It's not a big market for the products in the actual aerospace devices, planes or whatever. It's not a big market for our the insulation products and jacketing products we talked about today, but we have used some of them in there. But also remember that these companies have manufacturing facilities that might have climate control in them, or office buildings. And certainly our products have been used in the chilled water insulation systems at these kinds of facilities. As far as space or mil-spec applications, we meet quite a number of different products meet quite a number of different mil-specs. Our low-index Trymer product line, one of its biggest applications is in military shelters, which have a specific set of mil-specs and ASTM standards designed for the military shelters, and we meet other mil-specs as well.
All right, thank you, Jim. The next question is more of a comment, but maybe you could speak to this, and that is, you mentioned a 300 degrees Fahrenheit as the maximum operating temperature for your Trymer PIR. This is quite high when you compare it with other PIR products in Europe.
Well, we're clearly better. PIR is PIR. It's probably not that much different. I will say that we do run a higher index, which gives it a little bit higher temperature range. But the ASTM standard for PIR is an upper temperature limit of 300. So I suspect that even the lower index products will do fine at that temperature. That ASTM standard has been promulgated with input from the European manufacturers of PIR as well as the North American manufacturers, and the European manufacturers have not balked at it. I suspect, and I'm no expert in European PIR, but I suspect it's more just a function of history and what has been claimed in the past, and let's just make up a number and say they've always used 250 as their temperature limit, so that's what they've always claimed. In truth, the value proposition for closed cell insulations like Trymer at temperatures above ambient are reduced, and the closed cell PIR products are more expensive than fiberglass, for example. So unless you've got a reason to use a closed cell product like PIR, you probably are better off using fiberglass. So there's not a whole lot of reason to fight about small differences upper temperature limits in a market that is not that large for PIR. But hey, there will be PIR applications where someone has a need for a closed cell product, and maybe it's a wash down area. They're washing it. It's a food and beverage processing, which is usually cold, but once in a while they wash it down with hot water or steam, so it gets up to 250 or 300. So that might be an application where the Trymer PIR would be used. But I don't think it's a difference in the products. I just think it's a difference in the product claims, probably arising from historical choices.
All right, thank you. The next question is, what density Trymer should I use on a hanger support system that's 4x2 and 7x2? The
answer is it depends. I can't answer that. It depends on many more factors than were provided, and I'd have to calculate the results. The pipe contents matter. Is it molten mercury? Well, is it liquid mercury or is it gas? That'll change the weight of the pipe tremendously. What's the schedule of the pipe? What's the span between supports? If you're supporting it every 5 feet, marshmallows could support it. If you're supporting it every 100 feet, you might need cement blocks. So there's just too many variables to answer that kind of question. But if you want to call, get a hold of JM, either our technical support line who do these calculations very frequently, or your JM salesperson or anybody else you know, we can perform those calculations for you. We would have to get additional information.
All right, thank you. The next question is about K factors, Jim, and that is, since the K factor improves as the temperature decreases, can we assume that the K factor of Trymer approaching absolute zero is also much lower than LNG temperatures?
Yeah, all of the products kind of asymptote. You get diminishing returns. It still gets better. The thermal conductivity still gets better as you go to lower temperatures, but it starts to plateau a little bit. So you get a little bit of diminishing returns, but certainly the thermal conductivity at absolute zero or close to absolute zero, since you can't really get to absolute zero, is going to be better than at minus 265, which is at LNG temperature. But it's also critical to remember that when you're designing an insulation system, the insulation is at a whole bunch of temperatures. Let's say you put insulation on a minus 300, just to make the math easy, a minus 300 degree line, and it's 100 degrees outdoors. Your insulation is going to experience temperatures from minus 300 all the way up to plus 100, a 400 degree F temperature window. And so different parts of your insulation are going to be at every temperature between minus 300 and plus 100. And so every little bit of your insulation is going to have a little bit different thermal conductivity. This is part of what makes the calculations difficult to do. They can't be done directly. They have to be done iteratively with computer programs, or iteratively by hand, which of course no one does anymore. So even if you have a cryogenic situation, lots of your insulation is going to be operating at temperatures well warmer than the cryogenic temperature, pipe temperature. So those all have to be considered, and all the standard insulation thickness calculation methodologies take this into account.
All right, thank you, Jim. You explained that the lower temperature limit for Trymer was minus 297. Why is it okay that XPS is at minus 320? Yeah,
that's a really good question. We aren't always consistent, and neither is the industry. We did have minus 297 as the lower temperature limit for styrofoam pipe billet as well. The ASTM standard for that product was in the last couple of years changed to minus 320 at the request of a certain manufacturer. We generated data to support that change. And so the lower temperature limit for styrofoam in ASTM and in our literature is minus 320. The exact same issue of minus 297 in liquid oxygen would apply. The difference is, I don't know that I've ever heard of styrofoam being used at those kinds of cold temperatures. The issue would certainly apply, but at those kind of cold temperatures, Trymer is the much preferred product. Styrofoam really has its niche in food and beverage, which is maybe minus 100 on a, if you squint hard, once in a great while, but most of the time minus 60 to plus 40. So it would apply. It's a great question, and I hope that addresses it.
All right, thank you. The next question is there a big advantage to using a 0.0 perm jacket, rated jacket, compared to a 0.01 or 0.02?
No, not a big advantage. And the reason is joints and real-world performance versus lab testing performance. Remember that the tests that are done, the zero permeance test, the 0.01, the 0.02, are all going to be done on a perfectly intact, homogeneous sheet of vapor retarder that's probably roughly 6 inches by 6 inches in a controlled lab situation. What's the real world performance of that when you realize that, hey, you've got joints in there, you've got tape, you've got all these real world factors. There was a presentation given by Gordon Hart, if anybody knows him, at not a recent, but maybe 5 years ago, ASHRAE conference, that talked where he modeled the water entry and the long-term thermal conductivity performance of systems. And he found that as long as you were below 0.02 perms, that your system was pretty darn good for like a 20 to 30 year lifespan. You start to get above the 0.02 perms and you get more water in, enough to cause more problems with thermal conductivity. So I think in a real world situation, the difference between zero, claimed performance in a lab test and a 0.02 claimed performance is mitigated by the real-world installations, and both of them perform acceptably, probably better than acceptably. All of them below 0.02 are going to perform great.
All right, thank you. I think we have time for one more question, so let's finish on this one, and that is, are contractors required to be certified by Johns Manville to handle low temperature installation systems?
That's a real short one. The answer is no. We do not offer certification of contractors.
All right, that takes us to 15 past.
I'm sorry, Kim, let me just say, we do offer we do have lots of installation guidelines that can help specifiers write and inspect things, and we can help contractors learn how to use it or install our materials, but we don't have any kind of certification.
All right. That's right. Thanks so much, Jim. So that wraps up our time. We did have a number of questions we weren't able to get to, so if we didn't answer your question, we will reach out to you separately. Also, you can submit any questions you may still have via the survey at the end of the webinar. That'll pop up here on your screen. Your certificates of completion will be in your inbox next week. Otherwise, we hope you have a great weekend and you guys stay safe.
Thank you again for joining us, everyone. Have a good day.